Hey, what's up, everyone? Hello, hello. Welcome to lesson 3, where I still can't get my eyes unstuck, but here we are. Okay, so today's gonna be fun. We're gonna move straight to loops, which is gonna be exciting. So if you were here for the last lesson, you're actually gonna recognize what we have up here. So the game's gonna look very familiar to you. If you weren't, we do have the VODs up from lesson 1 and 2. 2 will be like the most important one where we sort of started looking into code and just sort of going through what's going on. Yeah, my eyes aren't fully charged yet. But that's what today is for. So I'm gonna do like maybe a quick recap just so I know there are some new faces today in class. And hopefully it's like fast enough that it won't be too boring to sit through, but maybe I'll catch up some of the newer people. So this is the game that we are working on. This should look pretty familiar to all of you. There's a new link in the description for this new lesson. So it's going to be a little bit different. It's still called Charge Aki. You can download the zip file from GitHub and then just extract it somewhere into your computer. And when you open up the HTML page, you'll basically see this. So if you guys remember last time, we made it so that this changes colors when we charge or empty the bar. At 0, like we start charging me with the plug, and also give us a little bit of a power, and then at 100 we take it off, right? So it's like super simple that way. This time, if you actually open up, there's like a new file here. I know that I kind of named them the same thing, so hopefully that doesn't get too confusing. But just make sure it's tagged simple loops. It'll be called simple loop starter code. Yes, link is in the description down below. Oh, I'm a YouTuber now, so I can say that. It's also on Twitter and Discord, in case you have easier access to those for some reason. But otherwise, once you get to this page, just download chargeaki.zip, and then open up the HTML page in a browser of your choice. I have Chrome open here, and then open up chargeaki.js in whatever code ID or text editor that you want to use. I'm using Sublime, so if you want your thing to look exactly like my thing, it's a pretty neat little tool, so you can also download that from the description down below. You had to rename it. Yeah, I probably should have done that. Like, I didn't think ahead very well for this because I don't plan out all the lessons in advance. I do them one at a time. And so by the time that I reached this one, I was like, hey, we could actually just build on top of what we already did. So that's my excuse for the naming discrepancy there. But yeah, anyway, so in the new one, if you open it up, you will see a little bit of a difference. So if I refresh here, what I showed you before is what we ended up with our last lesson, right? So this time though, you can see that the bar is gone, right? So I thought that with loops, it would actually be really fun to fill that part in, because last time that was part of the starter code. So it just kind of magically appeared for everyone. But this time, we're actually going to make the bar ourselves to indicate like how much of the battery is filled up. And yeah, I figure that way it's kind of like building the ship from inside out. We'll replace it like plank by plank. Although I don't know how much longer we're going to work on this one. We can probably just like, yeah, I'll play it by ear. I don't know what's happening with my eyes at all. Maybe, does this help? This did not help, but that's okay. We'll have a sleepy stream today. It's one of those weeks. Yes, the ship of Theseus. Anyway, so in your coding editor, open up chargeaki.js, and the first thing that you'll notice is actually some of the variables have changed. I've left in the ones that you'll need for this lesson, but I've moved everything else over to scripts.js. You don't need to worry about anything that's in here. This is kind of just things happening behind the scenes, so just know that they're there. 0% battery stream. That's why we're making this game, so I can get all the energy I need charged up. Yeah, VS Code is a really good one. Sublime, which is what I'm using right now, is just like a little lighter weight. But if you want like any built-in functionalities for other things, like that's the VS Code is a really good thing to use. There are also other ones, and like whatever you use really depends on what language you want to use. Today we're still using JavaScript, but we might switch that up later on. So we're going to teach this in a kind of language agnostic way where everything you learn can sort of just be applied to every other concept, or every other language. Speaking is hard when your battery is low. But I guess recap of what we learned last time, you'll remember that our lesson was on conditionals, right? So if you remember, a conditional tells the computer when to do something. And it's basically a statement that we give to the computer, and then the computer will think about whether it's true or false, right? So if you remember, we did if statements for that, where we had it in this format. This is an if block, and we had if some sort of condition, right? And we get to fill this in. And then we have like action 1, action 2, and then so on and so forth, right? And then if the computer, he thinks about this condition, right? And then he thinks, if this condition is true, then I'm going to do all these actions. And then we also had like else if blocks where we had like a different condition, right? And finally we had like else blocks as well to encompass every other action. So these are also actions, and these are also actions. So that was like a really quick and dirty explanation of what we learned last time. And you'll remember, like, we don't need else ifs with if blocks, and we don't need else's with if blocks. This is basically just us telling the computer when to do something. And it does those if what we tell it is true, right? So for example, if we say like if 1 + 1 = 2, or 3, that's not right, 2, then the computer will do whatever action is in here, right? Because 1 + 1 will always be equal to 2. And that's the syntax we use, equals equals, to compare. Because you'll remember that equals is to assign a value to a variable, right? And so this time, we're going to take the concept of conditions. We're going to build on top of that. And while we're telling a computer when to do something, right? So we actually want the computer to do things more than once. Like if we're taking this demo as an example, like how can we build up the bar? If we're thinking of it as like a very human approach, right? You'll remember that, okay, bar would be the new sort of variable that we need to fill it up. So I could put anything here, but I'm gonna put like, say 10 empty boxes, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this would actually just give us the bar. And then if we really wanted to, what we can do is use if conditions to like tell the computer when this bar should have like filled spaces, right? So we could actually do like if the battery is like, if battery divided by 10 is like 1, then we can add, so hopefully we're not losing anyone here. Battery divided by 10 is because battery can be up to 100, right? And since we have 10 bars, or 10 boxes within the bar, 100 divided by 10 shows you like how much is needed in each bar. So each bar represents like 10%. So hopefully we haven't jumped too far out of that. I know I didn't really explain that very well. But for example, like if we put that it equals 1, like we could obviously like fill this up and say, yeah, this is when 1 bar is full, right? 1 box full, which is around like 10% or like under. And then we could keep doing that, right? If we really wanted, we could keep doing this with like else ifs to, I guess, be more efficient. And then we could continue as like 2. And you'll remember, like, we can even use switch statements for that. But we don't want to do that, right? Like 10 times is maybe manageable. But imagine if we wanted a bar of like 100 boxes, right? Then you'll be sitting here copy and pasting for like the rest of the day. But the nice thing about the computer is that the computer can do things a lot faster than you can, right? Like it can do this in like a split second, even less than that. So you don't actually have to sit here copy and pasting this in order to tell the computer like, oh, when this specific thing happens, like do this. And then you don't want to like sit here pasting in the boxes. Tell that to the compiler, yeah. So what do? We can use loops, right? So loops are when we tell the computer to keep doing something, right? To do more than one thing. And one of the most simple loops is called a while loop. And it's gonna look very similar to what you just saw as an if block. Notepad++ does not like those bar boxes. If those bar boxes don't work for you, feel free to use like an O or like any letter of your choice to represent like the empty boxes, and like maybe a Q for like the full boxes. Whatever works for you. Yeah, if you change your encoding settings too, it'll render it for you. Because right now I think it's just interpreting it as the wrong bit character. So hopefully you can figure that out. But if not, feel free to join the Discord. I can help you out with that afterwards. But this looks really familiar, right? It looks very similar to the if block that we had, and it's gonna be very much the same in that it takes a condition that we can give the computer. And what this condition does is that it tells the computer when to stop doing something. Because we don't just want the computer to keep doing everything in this block, right? Forever. Because that's what it's gonna do if we don't tell it when to stop. And so we tell it using a condition, just like we did with the if statement, but the if statement only runs once. While loops run until this condition, evaluates to true. And so what it'll do is, if you have like actions here, right? We'll say like action 1, action 2, etc. So initially, the code's gonna like read all the way down here, right? And so the first time it reaches this, the very first time it says while condition, it doesn't even enter this block if it's not true. If condition is already false, it's just gonna skip past everything and keep going, right? But if it reaches here and it says, oh, this condition is true, it starts running this, right? It starts running this, it runs action 1, and then it runs action 2. It's very like sequential this way. It does it in order of exactly like how you write it. And then once it's done action 2, once it reaches the end of this block, it goes back to the condition and it checks the condition again, because it's checking if something has changed since the first time it ran it, right? So then if it sees that the condition is true again, it keeps going. And it goes twice and then 3 times, and then it keeps going until this condition is false, in which case it just skips everything and goes on to whatever other code that you have, right? So how can we use this? How can we use this for our battery bar? Okay, well, I guess the first thing that we can go over is, I guess, the simplest condition that we can use for a while statement. Or in general, the simplest condition that we can use is true equals true. And true equals true, anyone know what this will evaluate into? The computer looks at true equals true, it compares true to true, And it says, yep, that's right. True definitely equals true. And so this is something that's always true. This will give you an infinite loop. And the computer won't be able to break out of this because you've given it something that never changes and will always be true. Another way you can write this, if you remember from last time, is just while true. So while true, it'll keep running whatever actions are in here, right? The opposite of that is while false equals true. Yes, it's like flag is flag. It's like a tautology. If you've ever done any logic sort of lessons, it's basically true equals true is a tautology because it's always true. It's kind of a useless statement, but there is a use for it. We want to avoid using generally while true at all times if you can. At least when you're starting off programming, there are kind of reasons for it that you can argue for, but there are always usually better ways to do it. And so the opposite of that is false equals true. And false equals true. Anyone know what this is? Is false ever equal true? It's not, right? And you could also just write this as if false, because if you remember, like, we can use a switch here. This can either be true or false, and while false, we'll always evaluate to false here. Yeah, that's right. And so if you have while false, this will never run. The computer will just skip over everything here, right? So hopefully that was like a very quick crash course in conditionals. If you want a more sort of in-depth explanation of it, you can go to the previous lesson where we did conditionals. But let's break down this problem. So I kind of have this broken down into parts in the actual questions that I've given here. And so the first thing that we can do is, before we even consider which parts of the bar are filled, let's break it down to the simplest portion of the question, which is just to create a bar out of boxes. And any boxes, let's do like the very base case where every single box is just empty. So let's make a bar of just 10 boxes. And I say 10 arbitrarily. 10 is just the number that we used last time, and that gives us like the short bar. But we can change it to anything we want. But let's make one of 10 boxes for now, because that's like a nice round number for our battery, right? And 100% divides pretty evenly into 10. So how can we do that? Well, let's look at what condition we kind of need for that first. First of all, we have to reset our bar here, because every time we move this battery percentage up and down, this code is running. That's just how we've set it up. And so before we do anything, we should make sure that the bar is reset to nothing before we start building it. Are we using nested while loops for the problem? No, we're not actually. So that's actually a really good call out of something that we're gonna do later. And that's the fact that you can actually nest loops and if statements. And what that means is, like, you can have while statements inside of if statements, and you can have if statements inside of while statements. Like, you can have like ifs in here. You can have more while loops within while loops, right? And these would normally be filled, but we don't really have anything to fill them with right now. And that means, like, each time this while loop is run, it's going to run another loop inside of it. So it kind of gets a little bit more complicated that way. We're going to ignore that for now, and that's going to be a bit of a future lesson, because I'm actually splitting up loops into sort of this one and one more in the future once we finish learning about data types and a few more things. And so today we're just going to go to like the bare basics of loops. So today we're only doing basic loops that are not nested. So there's only going to be one loop and at a time, let's say. And so let's see. Using a while loop, how do we make a bar full of 10 empty boxes, right? Well, in order for us to give a condition to the computer, we kind of need to keep track of how many empty boxes the computer has already sort of added to this bar, right? So let's think about the action that the computer needs to take. How we add a box to the bar. Here, we can use this character. Actually, let's use this notation first. So bar equals bar plus this, right? Let's get rid of the while statement first. And let's show you what this is actually going to run. If we have bar as empty, like it's nothing, right? If I run that, you can actually see, yeah, there's nothing here. It's actually in here somewhere, it's displaying, but since it's an empty string, it has nothing to display. So it exists in here right now, but it's just not showing anything. Now, if we add bar equals itself plus this empty box, right? Itself plus an empty box is just one empty box. Oops. Sorry, ignore that. It's just one empty box, right? And we can actually keep doing that. If we duplicate this statement, bar equals bar plus empty box, it'll keep adding empty boxes to itself, right? And you can do this with any number of like characters. Like you can type like empty box and like words, and it'll just type this. And you can even keep like adding to it, equals bar plus something else. And you'll see that it just combines this, the new thing that you're adding, with itself, with whatever is contained within itself right now. So that shows this, right? That's kind of what we expect. But another easier way to write this is actually bar, we remove the bar plus equals. Now this is an addition sort of assignment. And it's saying the exact same thing. Bar equals bar plus this. It's saying the exact same thing as this, but it's just an easier way to write it. So that's like a useful thing to know, is the plus equal operator. Instead of just putting equal, plus equals mean add whatever this is to yourself, right? Because if we just did bar equals this, right? Initially we'd get the same thing, because if bar equals 1 square, that's all we need, right? We only needed 1 square. We only needed 1 square. But if we do plus equals this, it adds 1 more square to itself. Like if I remove this right here and only had bar equals empty box and bar equals empty box, what would this give me? This would just give me 1 empty box, right? Because we're not adding to it. We're just telling it that this is the data that you hold. We're just overwriting everything in bar. So even though we made bar equal an empty box here, the second time we do it, just overwrites it. So the computer is thinking, oh, bar is empty box. And then, oh, bar is empty box again. So that's done. But if we do plus equals the empty box, then it'll add this empty box to the previous empty box, to whatever is in here, right? So it'll show 2 boxes here. Like if I type 1 here and 2 here, it'll show 12, right? Because 1 is the initial value, and then it adds 2 as a string, right? Yes, if you do a while true loop, it'll make Google Chrome crash, because what it's doing is it's taking all your resources and using it towards that. It's taking like the attention of Google Chrome, if you want to think about it that way. So that tab can only be running that, and it runs it at an incredibly fast speed. And it keeps going. So that's the fun part about infinite loops. If you have while true, I could probably show it off actually. If you have while true, this will just keep loading and nothing will happen. I know you guys can't see my tab right here, but it's showing the little spinny circle and it's gonna keep doing that. And now you can see like nothing happens, right? Oh, and page unresponsive. So we're gonna get rid of that, because that shows us what not to do. And then, whoops, let's just reopen it. Charge aki.html. Bring it back. Oh, we can zoom in. Yes, sir. Does that look a little bit better? I know that the screen space is very limited right now. Hopefully that makes it a little better. I know that I personally use my text editor at a very small font size. So I hadn't considered that, but hopefully that looks a little bit better to you. If not, I'll just zoom in a little bit more. But hopefully I can avoid doing that. All right, so now that we know how to add boxes to our bar, now that we know like the mechanism involved in that, we can take this. Let's get rid of what we had before, right? So we can commentate this as add a bar or add a box to the bar, right? And then we'll get rid of this because this is saying exactly the same thing. It's just another way to write it, you know? What's up, Daisy? No worries. We're just sort of getting started here. Okay, so now that we know the action that we have to take within the while loop, what condition do we use? Well, let's think. How do we know that we've reached 10 boxes in the bar? We don't currently have a way, right? So let's make some sort of variable to track how long the bar is. So we can call it anything we want. I'm gonna call it length. You can even you can call it like I or like X. You can call it Bill. You can call it anything. Generally, when you're writing code, you want to make sure that whatever you're writing is really easy to read and understand. So I'm gonna call it length. It's a really good practice to get into, especially like you'll thank yourself later if you come back to this code and then you look at it and you're like, well, what the fuck is Bill? Who is that? So name your variables properly if you can. Okay, so what length do we start at? Well, for coding, normally we start counting at 0. It's a little bit different than how we normally count as humans. Oh, I say we, but I'm not really a human, I guess. So 0 is where programs and the computer counts normally. You could start at 1 if you really wanted to here, but since most other things start at 0, it's a lot less confusing to just start at 0 from the get-go. Yeah, you can also comment what it means, but like at a glance, like think about using the same variable over and over. You don't want to have to add a comment, like especially if your code is really long, you don't want to have to add it like down the line or like look for where you declared that variable and where you had the comment. So it's a lot easier just to like have the name of the variable mean something. Since it's like it's free anyway. I generally also just use like 1-letter names because I'm lazy and it's easier. But since we're starting you guys off on probably good, hopefully, programming practices, we're gonna name it properly. And also it's easier to reference this way, so I don't have to give you a bunch of different letters. I'll leave that up to Tane and her English class. So now that we have this length, right? When did we say we want to stop adding boxes? Well, we said we wanted a bar of 10 boxes, right? So we can say when length is less than 10, right? Does that make sense to everyone? When the length of the bar that we're currently adding to, that we're currently creating, reaches 10, we want it to stop. But anything under that, we want the loop to keep going. right? And so what will happen if I run this right now? Does anyone know? I'll give everyone a moment to think about it. What will happen? So you'll notice this is actually exactly the same as the while true loop. I might as well have put while true here, because what this is saying right now is while 0 is less than 10, keep doing this loop. And so this is an infinite loop, right? Exactly. Good job, everyone. Okay, so how do we stop that? Well, we actually need to add something to length each time that we're adding a box. We need to update it, right? And so the way that we just do that is at the end of the while loop. At the end is important because we want all the actions to happen before we actually add to length, right? And this is kind of easy because there's only one action that we need to do. And yeah, everyone already said it. We need to increment. So length equals length plus 1. But what's an easier way to write this? We actually, we just learned something that can simplify this a little bit, right? So length equals length plus 1. Since we're adding 1 to itself, we can get rid of the length plus part and just use a plus equal operator, right? So we can do length plus equals 1. And this adds 1 to length. But I'm going to teach everyone one last secret thing. An easier way, because this is 1, there's actually another operator that does this automatically for you. And that is plus plus. What plus plus will do is add 1 to whatever variable you put here. And you could also put it in front of your variable. You can put plus plus length. So all of what I wrote was the same thing. We're doing the exact same thing, whether it's length equals length plus 1, or length plus equals 1, or length plus plus, or plus plus length. That was a lot of words. But this is an easy way to add 1 to whatever variable you're working with. Just remember that. You're going to see this a lot, plus plus. Now, there is a little bit of a difference between adding plus plus to the beginning of the variable versus adding it to the end. In this line, it won't matter. In this line, it won't matter. These are called pre and post increments. So if they're before the variable, it's a pre-increment, and it does it before evaluating a statement. And afterwards, it's called a post increment. You don't need to remember any of this. None of this is relevant to what we're doing, but it's just one of those for fun things that I might expand upon, like maybe in a later lesson. Since this is literally just incrementing a variable, it doesn't matter. But it does start mattering once you get into more advanced statements. But for now, you can use whichever you like. Just, I would suggest keeping it consistent. So if you pick one, stick to it. Either do like pre-increment or post-increment, just so you remember in your head like what it does, and just so you start recognizing it. When would it make a difference? It makes a really big difference because you can actually use this when assigning things. Like if you had like a variable x equals like 1. So this is like a bit of a tangent. You don't really need to know this right now. But like, for example, here, we'll call it a, why not? Just so we started off like at the front of our minds. And then you had like variable b equals 0, bar b. That's not what I meant to do, right? So if you had that, if you did like variable c equals a plus b, you can do that, right? And that'll give you 0 because it's 1 plus 0. But if you do a plus 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 b, that gives you something different, right? If you do a plus 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 b, it'll actually do this after it evaluates the statement. So c will actually still be 1 plus 0. It'll be 1. But if you do plus plus a, it'll add to a first. It'll add to a first. So this will become 2, right? This will be 2 plus 0. And so c will equal 2 instead of 1. So it does start making a lot of difference later on. But right now, you literally just don't need to worry about it. But that's like a fun little tangent that we went on. And so now that we're adding to the length, this should actually give us what we want, right? So let's walk through this. So length starts at 0. The while loop, the computer will come to the while loop and say, oh, 0 is less than 10. So it'll do this, right? Then, here, we can actually write this down. Step 1 is 0 is less than 10, which equals false, right? What about step 2? Let's actually do a different comment block. Oops. So we don't have to keep writing 2 slashes in front. Yeah, plus plus in the back basically just means do that after the whole statement has been executed. That's a better way to think about it, I think. Normally though, let you in on a little secret. Plus plus at the beginning, if it means the same thing, will usually be like a tiny bit more efficient. And the reason for that is because when you put it at the beginning, the computer doesn't need to store the variable as a temporary variable, because in order to add to it afterwards, it actually has to make some space in its memory just to remember like what it's adding to, right? Because it needs the first value and the second value if you add plus plus to the end. But if you add it to the beginning, the computer knows like, oh, we don't care about that value anyway, so we're just gonna go ahead and do that. But that's the differentiation. But yeah, so the first time we go through this loop, it's 0 is less than 1, right? Which is false, and then it actually adds a bar. So that's already 1 bar, right? So we'll do bar equals this. So I'm only gonna be walking through this like very in depth for this first while loop, just so you sort of get like a clear look at what the computer is actually doing. And so the second time, once we reach like this part of the loop, the computer will go all the way back to the front and look again. But this time length, we increased length by 1, right? We did length plus plus or plus plus length, whichever you did. So now length will be 1, which is less than 10, right? Or sorry, this is true. I don't know why I put false there. This is true as well. And now bar will equal two boxes, right? And the third time we go through, it'll be like 2 is less than 10 equals true, and then bar will equal 3 of these, right? And so it'll go do that all the way until the 10th run, in which length will equal 9. Because remember, we started at 0. So it's 0 to 9 instead of 1 to 10. That's like a little bit of a thing to wrap your head around. But once it reaches the 10th run, it'll be 9 is less than 10. Sorry, it'll be 10 actually, because we put less than 10. Equals false, because 10 is not less than 10. And then bar will equal the 10 over here, right? Right, so if we run this, we'll see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bars, or 10 boxes in the bar. I should have used better names to differentiate them, but boxes and bars, we'll get there, So that's actually already question 1I. I don't know why I use I's. I should have used A, B, C, but it's okay. They mean the same thing. So that's our first loop, right? That seemed pretty intuitive, hopefully. It's very much the same as what we did with the if statements, where we just need to sort of, in our minds, break out the condition that we want to set for the computer and the actions that we want the computer to take. What's up, Kismet? Welcome to the stream. So now that we have our first while loop, how do we start adding it so that we start seeing the filled in boxes for the actual bar? No worries on being late. We're just sort of going through sort of how to do while loops. So let's see. Let's take a look at this second one. what we can do, one way that we can do it, is to actually split up this into filled boxes versus empty boxes, right? Like we could use one loop for all of the filled boxes and then do one loop for all of the empty boxes. So, let's make 2 while loops initially. Now, can anyone tell me what we want to do first? Do we want to do the filled ones first or the empty ones first? I'll let you think about that for just a second. Because I know there's a little bit of a stream delay, so I probably won't be able to see if anyone says anything until like a second later or something. Filled first, yes. And how do we know that? It's because we're adding boxes from the left to the right. Remember when we added bar plus equals this little empty box, right? I guess, yeah, it adds one empty box to nothing, right? But a way that we can visualize that is adding like, here, let's add A, because it's probably easier to visualize. If we add A to that, it starts on the left, very much like how humans write. And then if we add a B after that, it adds it to the right side because it's just adding to the end of whatever the stream is. Hi, Fuchsia. Welcome to class. This is lesson 3. We're on loops. And like, we can keep going. Like it keeps adding anything we put here to the end of whatever bar was already, right? And so what we can do with that, is, here, let me just get rid of this. I'll take this over. So the first thing that we'll do is the filled section, and we can actually annotate that so we remember what it is. Yes, I am a VTuber live coder. I am your pocket programming pal, LITE, here to teach you how to program. So let's do something similar to what we did for this set of 10 empty boxes. But instead, we'll make it depend on how many are filled boxes and how many are unfilled boxes based on the battery level. And so the first thing we'll have to do is reset the bar again because we've already done something here, right? We've already done all this here. And so we kind of want to overwrite bar. So what I just added here, like you'll remember that the code that we just wrote adds 10 empty boxes, right? It adds 10 empty boxes, but once we reset it, so we clear it with like 2 empty quotes. This is just an empty string that we went over last time. It clears it to nothing, right? Anything you write here, anything you assign to bar, will just overwrite whatever we did before it. And so that's like an easy way to think about it. And so for the filled part of the bar, let's do another while loop, right? And this time we're gonna be using the filled boxes. Does minus minus subtract 1? Yes, it does. So plus plus and minus minus work the exact same way, but just in opposite directions. So if you ever need to subtract 1 from something, then you can use minus minus. And the same sort of pre and post sort of conditions apply for the minus minus operation, which is called, it's like the decrement indicator. Yeah, so for the filled part of the loop, this is actually gonna look very similar, right? So let's do the action first because we already know what has to be done for the filled part. So obviously it would be the same as this, but with a filled bar instead, right? Or a filled box instead. So it'd be bar plus equals this black box. Can you use length plus plus? Yes, you can. If you go through the VODs a little later, I have like a little, it's like a little section saying why you can use it and what the differences are. But yeah, essentially you can think of it as you can use all of the things like length equals length plus 1, length plus equals 1, plus plus length, and length plus plus interchangeably right now. But yeah, you can choose whichever of those you like better. Obviously, like plus plus length or length plus plus will be shorter to write, and we generally have a preference for things like that. But if you want to write it out so it's easier for you to understand, that works too. Like whatever is easier to understand will make it so that you make fewer mistakes, or that you can catch your mistakes earlier, because the computer will interpret it the same way either way, in most situations. So now that we're doing the action, what is the condition that we need to add to here? This time it's going to be a little bit different, right? Because we're not doing this 10 times, because the length of the filled boxes will be different depending on what battery level we set to it, right? And so it's still going to depend on length. We still need to use this new length variable. And this mostly just lets us keep track of how many times we've run through the loop. And it's also the same as how many boxes we have right now. And so how do we figure out what this should be? What are we comparing length to? Well, if you remember, we have this variable, battery. It can go from 0 to 100. Because if you think about it, it's like a percentage indicator, same as like on your phone or any other electronics. And we said that each bar is 10 because there are 10 bars, right? So since we're going to have 10 boxes, we can do battery divided by 10, right? Hopefully I haven't lost anyone here. So this way, we can actually just check it, right? If we refresh this, ooh, something went wrong. And that's because we forgot to increment length again. So last time I did it because I was showing you guys what it meant to have an infinite loop. This time we just forgot to increment it. So make sure to increment your loop so it's not stuck in there forever. And so this way you'll see we're at 50% and it's showing 5 loops, right? Because each of these is 10%. And so you'll see that as I change this, we get fewer and fewer, or like if we go higher, we can get more pips, right? Up to a maximum of 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So this is what we want for the filled section. Now, what do we want? What do we want for the empty section? So let's make an empty section. We'll do another while loop after we do this to fill up the rest of the bar. I'm gonna open this on a different browser. Good idea. So I think Chrome and most modern browsers actually limit it to like 1 tab, but if it uses all the resources, then it might crash you. It shouldn't though. So usually it'll only crash 1 tab at a time. So this is for the most part pretty safe. It shouldn't really do any long-lasting effects. The worst thing is maybe you have to go to Task Manager and just kill your browser. But let's do the empty one. It's going to look very much similar to this, right? So we're going to go back to using an empty bar for this one, right? So now this is going to look exactly the same as what we had before. But you'll notice that we don't want to reset the length anymore, right? And we still want the total bar to be 10 boxes long. And so what we can do is actually just do length is less than 10. So we can use exactly the same thing. And since we're not starting at 0 anymore, this will just fill out the bar with boxes if it needs filling out. Like if we're at the point where battery is 100, this will run and then it'll get to here and say, oh, well, length is already 10. So we can skip this whole thing, right? So that's how this bar sort of works. And then make sure we're incrementing our length again, just so nothing bad happens. So now you'll see we're very much in the same place as where we were last lesson, right? Except we've created this bar by ourselves now. And you can test it with like any values. Make sure that the threshold is like at the 1, or try it at a bunch of different percentages. And it should act exactly the same way as how we ended up with our game in the last lesson. Yep, exactly. The length is continued on because the computer is already storing this. And since we don't reset what the variable value is, like we don't put length equals 0 here, right? If we put length equals 0 here, then it would give us too many boxes. It would give us whatever the filled number is plus 10 empty boxes. I can show you what that looks like, which is definitely not what we want, because at 100, that just doubles our bar. So not resetting the length is what we want, actually. And now it's fully functional, right? It's perfect. Cool. Hopefully that made sense to everyone. That's pretty much like all there is to while loops. There's another way that we can actually do this with if statements as well. And so that's question 3 here. Question 3 I's. I don't know how to pronounce that. I. Question I. I guess they're supposed to be Roman numerals. Surely I know this because I wrote this, but it's a little bit too much for me at low battery. So now let's try doing it with just one while loop, right? And an if block. So this will let us sort of combine our logic together and sort of simplify it in a way that is maybe a little bit more compact and easier to read. And so first thing we need to do is reset everything, right? Remember, we have to reset everything to sort of clear what we did before. And so when we're doing this, like it just gets rid of the bar again, right? If you remember, like bar gets rid of the boxes, and then length equals 0 just resets the counter that we've been using back to 0. So it's telling us, hey, we have a bar of 0 boxes now again. That's what we're using it to represent. And so how are we going to do this with only one while loop, right? If you take a look at these 2 while loops, so it's going from 0 to battery divided by 10. And then it's going pretty much from battery divided by 10 all the way to 10. And so if you're looking at that range, right? Like for example, if battery divided by 10 is like 5, which is like exactly the halfway point, right? It's going like 0 to 10, and then, or 5, and then it's going like from 5 to 10, right? And then this boundary kind of matters actually. So it actually goes from like 6 to 10. So 0 to 5 and then 6 to 10. Well, there's an easier way we can write that, right? These 2 ranges, 0 to 5 and 6 to 10, is the same as saying 0 to 10, right? So with that, we can actually combine them both into one while loop, where we do length is less than 10. So we're just using our initial condition from before. Length is 0, right? So this is a loop that goes from 0 to 10. It runs 10 times. And when I say 0 to 10, I mean it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Because once it reaches 10, it doesn't sort of go into this loop anymore because this condition is no longer true. And so that's like a little tricky part about 0 indexing, is you kind of need to think of things as if they start from 0. That's how programming is just done. For a good reason, but it does get a little bit confusing if you're sort of looking at it in a new way and you're used to counting from 1. So always just think about like what's included in this and what's like the boundary excluded from this, right? So sometimes it'll help to write things down like what we did before, where we wrote down like what each iteration of the loop does. And so an iteration is just like each run of the loop. So each time all of these actions go once and then it repeats back to where it is, right? And so how are we going to do this with one loop? Now that we have it in one loop, how do we actually differentiate or have the computer differentiate whether it should put an empty box or a filled box? Yeah, by practice, counting from 0 will be second nature to you. So things will actually start looking weird to you when they start from 1. which is like a funny thing, but it'll switch at some point for you. And sometimes you'll just get used to looking at both. So it comes with practice. And so you should do this for practice. But looking at this, well, what's something we can use to tell the computer when to do certain things? If statements, right? We already sort of gave that to you. If something, else something, right? So we said we wanted to start with filled first, and the same situation applies here. Yes, use if else. Count as computer, not as monkey. Exactly. So we're gonna do the filled part of this first, right? Let's add a comment so we remember that these are the filled ones, and then these ones are the empty ones. And then we'll just add a bit more space so we can read it a lot easier. How do we determine what this condition should be? Actually, let's do the action first, because the action we already know. The action is just bar plus equals this, right? And then for the empty one, it's bar plus equals the empty box. And we just need to remember to increment our loop again. Make sure this is at the very end, right? Because we want all the actions to be finished by the computer before he adds the increment. It doesn't actually matter that this is at the end or not, because we're not checking the condition until after, but it does help you sort of debug it if you're doing like any sort of logging here. Like, for example, as you're doing this, you can actually print it out. Remember, we had console.log. You can print out the length to see like what the computer is actually doing. There are, we can say there are like this many amount of boxes, right? And I would suggest, like, if your loop has any problems, or if it's printing the wrong thing, or if you see like the wrong number of boxes display, like, it's really useful to add these just so you know like what it's actually doing, and that way you can diagnose when you make the mistakes. What if you want to return to monkey? You can go to the jungle. And so we can actually take a look at what's happening in the oh, here. I forgot a bracket somewhere. Give me 1 second. This is where I put an M instead of a comma. See, and that's where consoles are really useful for you. And so if you remember from last time, how you open this is Control-Shift-I. In some browsers, it's Control-Shift-J. If you're using Chrome, it's both, because why not? Or you can open it through just like the 3 dots at the top, and then if you go into more tools, developer tools, you'll be able to find it here. And this is just like an easy way for you to sort of print out what you're doing. So you'll see that I wrote there are length boxes, and each time this runs, since this is within the while loop, it's printing that out. So there are 0 boxes, 1 boxes, 2 boxes, all the way up to 9, right? So that's showing us what it's doing. If I were to put the length increment before this, it would actually start counting at 1, because it'll add 1 to the length before we actually do that, right? And this is actually where the post and pre-increment come in. You don't need to know about this really, but like, for example, if you do plus length, it'll print this out before it adds, or sorry, yeah, it'll add it first and then it'll print it out. And then if you put it afterwards, it'll print it out right before it adds to length. So that's one of the differences that you can see. And so you could leave that in, but I'm going to take it out for now just because we sort of already know what it does. And now that we have the 2 actions that the computer could possibly take, either add a filled box to the bar or add an empty box to the bar, what condition do we want here? Well, it's going to be very similar to what we did before, right? Like, the filled boxes will only be added to the bar if the battery is, if the length is under the battery percentage, right, at that time. So what we could do, what we could do here is sort of use the same condition there, right? Like we could use if length is less than battery divided by 10, then do this, right? Then do the filled bar, add the filled bar in the filled box into the bar. And we could put else if, and then we can do like battery divided by 10 is like less than 10, but we don't need to, right? We don't even need to put another condition here because it's either filled or empty. There are only two states. And so in order to capture all the rest of the conditions, any other case that's not captured in this part of the if statement, it already will just go to here automatically, right? So we don't even need another condition here. And that saves us some time typing, and that saves us some time thinking. Pre-increment and post-increment civil war. True. But objectively, pre-increment is better for memory. It doesn't matter when we're doing a small program like this. It starts mattering a lot when you're doing like very complex calculations for the computer. But for now, you can use whatever you want. You could even type out length equals length plus 1 if you really wanted to. So this should actually run, right? Like, let's walk through what we're doing. We're doing a full loop 10 times, right? And each time the computer runs through this loop, it's checking whether or not we're under the battery threshold. And the battery percentage threshold, if we are under it, we'll add a filled box. And if we're not under it, we'll add an empty box to pad it, right? And then we'll just increment it so the loop doesn't go on forever, because we know that for sure one of these will run, and for sure one box will be added to the bar each run of the loop. So if we refresh this, yay, it looks like it's doing what we want it to do. And we can just test that by going to different sort of increments of battery percentage. We can go to 100, make sure everything's working. Cool. The argument ends when you realize the compiler puts it in the right place. Yes, but it depends on when the compiler does that and what it compiles it to. So there's like a very slight difference, but it's really not a big deal for like when you're in like this area of programming right now. Okay, so now we've done the same thing in like 2 different ways, right? Both of these are like equivalent, but this one's maybe a little bit easier to read, or maybe this one's easier to read for you. Essentially what we're doing is like exactly the same thing, even from the computer's standpoint. So really, like, either of these would have been acceptable answers. It's just good practice to like get to know different approaches that you can use to make whatever you're trying to make, right? And like having your mind be able to come up with these is like how you get good at programming. It's like problem solving, right? And pattern recognition. And so like, how can I make the computer do this based on like all these variables I have and like all the data that I'm feeding it. So that's essentially what we're trying to do. Now you will notice if if you were paying attention that there were 2 new variable looking things added here. Now what are these? Const. They're a little bit different than variables. What constant variables is what they're called. What constant variables are variables that are meant to be read only. So once you set them at the beginning of your code, you can't change the value. You're telling the computer like this value is always going to be the same. And why do we want to use this? Well, you'll notice that in our code, even though we're doing the same thing over and over, like obviously we could delete like 2 of these and have it do the same thing, right? Because we realistically only need like 1 of those. But say your code is like this long. What happens if you want to change how many boxes are in a bar? What happens if you want to change the length of a bar, right? Like you don't want to have to go through and like search, oh, here's 10, I want to like change it to 20 or something, right? it gets really confusing if you start doing that. And especially like, you don't want to be in a place where you're digging through all of your code and trying to find like the one instance that you forgot to change, because it does get really hard to look at, especially if your code gets really long. And so normally we don't want to put values by themselves. These are called hard-coded values, right? Because they're not stored within a variable. We're just typing a number and we're saying, yeah, that's the number that we want to use, and we're going to want to use that forever. And that might not necessarily be true. And so usually it's a lot better if you have numbers like these that you're going to use. Even if you don't expect them to change, it's good to take them out and put them within another variable. If you know for sure it's not going to change, and to force it to never change, you can use something called a constant. And you can use this in like a very similar way as how you use variables, but you'll just write const instead of var, you know? I just realized I wrote var. Isn't that cute? I'm a poet and I didn't even know it. But anyway, I've defined two of these for you. One of them is max length and one of them is percent per box. And the reason you'll need percent per box is because we started using 10 as the length, we did battery divided by 10, right? Because 100 divided by 10 is 10. But this will be different depending on what length you actually use, because it'll be the opposite. So like, for example, if I did like a bar of 20, right? Then each pip would actually be 5 instead of 20. So we wouldn't do battery divided by 20, it would actually be battery divided by 5. So var setting a car, exactly. But let's, as a bonus question, so we're already skipping a little bit ahead because I added it as a bonus question, but it'll be a lot easier to sort of add that in right now. So now that we finished question 1, let's go back through all of this and make it so that every time that we wrote a number in a condition, right, that we're comparing it to, we'll just link it all back to this one variable, this one constant max length. And max length refers to the maximum number of boxes in the bar. I was good, and I commented my code so you guys can all tell what we're doing. That's me, Rap God, in the house, as they say. But let's use this so that if we change this one variable, there's only like one place we need to change it, instead of like however many times this is. Let's see. We have it like a bunch of different 1, 2, 3, 4, 5. It's like 4 times. Okay, I guess it wasn't that many, but it gets to be a lot if you're doing anything else. This is like a short program, but even now, like, imagine the pain that'll take to like go through and like change all of these to like, oh, I want this to be 20, I want this to be 5, you know, like you obviously want it to be as easy as possible, and that way like you make fewer mistakes, right? And so let's go through and just replace any 10 we have where it's meaning length to max length, right? So length is less than max length. This is still saying if 0 is less than 10, and then if 1 is less than 10 as it runs, then 2 is less than 10, then 3 is less than 10. It's saying the exact same thing, but now we're like, we have this nice new box to hold it in that the computer is remembering for us, so we don't have to keep typing this. And length is less than max length. And then for battery divided by 10, we actually need to use percent per box. It was that nice round 10 number because 100 divided by 10 happens to be like the square of it. But this is this will be more versatile because it'll actually let us change like the length on the fly, right? And so now if we rerun this, it should be exactly the same, because remember, we haven't changed the length. We still made the length 10, right? We've just put it in another place and linked it all to this variable, this constant variable, right? And now though, if we do want to change it to like 20, this will automatically change it to 20 for us. Like, look at that. Isn't that nice? So we can have a bar of any number of boxes that we want. We can have it as like 100. I don't think 100 will fit here, but we can if we really want to, right? We can do whatever we want. And so just imagine like how much easier this is with programming instead of just like having us paste every single box. Like imagine having to go through and paste else if statements for every single empty box and for every single combination of boxes. So one where you have one box out of 100 filled and one where you have 2 out of 100 filled and so on. So this is so much easier, right? And that's what loops are great for. Loops and conditionals, these two lessons are like pretty much the core of programming. Like once you know how to do these things, you realistically know how to do like so much of programming already. Now, obviously there are like a lot of more difficult things you can do with programming, but like at its core, like these two are like such good tools for your whatever you're trying to do. And like thinking about this, like think of how powerful a computer is. Like you can use it for anything. Like you can use it, like you use calculators probably. An Excel sheet is like a form of sort of scripting, right? And like there are just so many things you could do like with scripts and with programming. So these two things, super important. Once you get these down, Pat, like you're gonna be already really good at programming. long man, exactly. So now that we learn while loops, what's next? Do you guys realize like how every time we have to like set the length variable or like whatever you named your counter variable to like track how many times the loop has run in order to have like this condition? There's actually a loop for that is sort of built to have counters already. So it makes it a little bit easier. So if you have a loop where you want to tell the computer how many times to do something and you sort of have an idea of like that incremental, like how many times you want to do it and like a maximum for when they should stop doing it, then there's something called a for loop. And that's actually, it brings us to our next question. A for loop has a built-in counter. So it's going to look a little bit, it looks kind of similar to the while loop, but like a little bit different. So it's going to look like this, right? Like it looks like your if blocks and it looks like your while blocks, but within here, within where you would normally put the condition, right? Within here, you can actually have 3 different things. And that sounds super daunting, but we're gonna go through this and you'll actually see that it's like super easy. So the first thing that we have here is like any sort of variables that you want to declare. And these variables will only live for as long as this block is active, right? If you declare them in here. If you declare them elsewhere, you can still use them here, but they'll live outside of it. It's like within this scope is what it's called. So the general format is for variables where you do like variable declarations or assignments. And you'll remember that like declarations look like variable x equals 0 or something. And then assignment looks like assignment looks like x equals 1 or something like that, right? Declaration you can also write as like variable x. It's basically just like when you give the computer a variable name and you're telling it, hey, I'm gonna give you information. That's what a declaration is. You don't have to add anything here yet, but you could. You could give it a variable name with an initial value already. Or you could just give it the variable name x and say, yeah, I'm gonna give you the information later, just make some space for it. And that's what a declaration is. An assignment is just when you use this equal sign, you're putting whatever this information is into the variable, right? Into the space that you already made, that you already told the computer to make. And so this assignment is saying assign the number 1 to x. So that's what declarations and assignments are. The next part of for loops is the condition. The condition. And this is going to look very familiar to you because this is the part that is actually like a while loop, right? The next part is actually the counter. So all of these you've seen before, but now we're just writing it in a different way that's like built into the actual loop. And so this is just the increment or the decrement, because you can actually do like plus plus or minus minus here. You can also do like plus any number or like minus any number. You can do like plus equals 10 or like however big the range or like however big the increment is that you want. You can put it there. And so I know this probably looks, or it might look a little bit confusing right now, but once we break it down, you're gonna be like, oh yeah, that's pretty much just what we did. And so variable declaration, let's first make a while loop that just prints out like the numbers from 0 to 10, right? So variable declaration, we can actually write variable, you can put like length or 1 or whatever equals 0, right? So that's pretty much what we did here. Length equals 0. Then is the condition, right? And then we're saying let's print out the numbers from 0 to 10. So we want to run this 10 times. So if it starts at 0, then we obviously want length is less than 10. This is starting to look like very similar to what we did before, except instead of like max length, we're using 10, like what we started with in the beginning. And so what do you think the increment and decrement is? This is going to be really easy for you because this is exactly what we were doing before. Plus plus length, right? This is a for loop. This is a for loop. And then in order to print out the number, we'll just print out the length. Why not? Because we already have a variable tracking it. So what this will do is at the very beginning of the loop, the for loop will make this variable called length. It'll make this variable. And length will only exist within the scope of this variable, right? And normally we'll want to name it something different from our other variables because this will conflict with like up here. So you want it to have like its own name, right? But we can just comment all this out. So that's not a problem for us right now. And so what this will do is we can take a look. It'll print out 0 to 9. Which is exactly what we wanted it to do. Or sorry, I put 10, but I meant 9. I'm pretty sure I also said 9, but I keep saying the wrong number. I hope that's not too confusing. So now that we have this, you can already see like this condition or this part of the condition already looks really similar to like everything we were doing before. So if we bring back everything we were doing before, just so you can see the nice colors for reference. You do take it that semicolons are necessary within the for loop? Yes, they are necessary because that's how the computer separates these statements. Like if you had this without the semicolons, whoops. Like the computer doesn't know what this means, right? It's going to say variable length equals 0, length less than 10. So it's going to try to assign this whole thing to equals, or depending on like what the compiler does, how it interprets the sentence, it's going to know something's wrong. It's not going to know like when to end the statement or like where each statement is. It's just going to try to interpret this as one full statement. So it is necessary to put as like 3 separate distinct things. And so we're going to rename this I for now, just so it doesn't conflict with like this variable. Because we already told the computer that there's a variable called length. So we can't tell the computer there's another variable called length because it's going to get confused. It won't let us do that actually, because it knows that it already has something in its storage called length. And so a different thing that you can do actually is you can actually take the declaration out of here. If you want to use I like somewhere else in your code, you can put it out here. And then next time you can also print it out here, right? And that does the same thing. Like you'll notice that like if you don't take out I, once you try to print out I, it's not going to really know what that is. I don't know why it's printing this out. Hang on. I guess JavaScript is just special. I don't know what's happening. But normally, in most regular languages, you won't be able to use the variable outside of this scope because it doesn't exist yet. It only goes within here, and then the computer just tosses it because it's just a temporary variable. So that's what normal languages do. As I said in the first lesson, JavaScript does some fucky things. It does it for a very good reason, actually, and it's because it's based upon the concept of objects, and it handles memory really differently. But you don't need to know about any of that. Don't worry about like the weird things that JavaScript does. Just take this as like how normal languages would do something like this. But you could write it like that. You could write variable I out here and do like the assignment in here. Yes, JS is the weird uncle, but you still love him. And I probably should have checked these before because JavaScript has some like weird intricacies that it likes to do. It's like some weird quirks about it. So you could put the variable out here, and normally that lets you use the variable like anywhere outside your variable after it. Or you could actually just purely do it out here and then make sure you have the semicolon here. But you could run this. You could run this with just this code and it would work. You could also take this out and then put this here and it would work. But like these are just things you could do. Usually you don't want to do it because it really kind of goes against what the loop is for. So if you find yourself starting to do that for a reason that isn't a good reason, or if you don't have any justification for it, just don't do it. This will be basically what you use for loops for. Yeah, JS is messing with you. It's going to look really similar to C++ though. So anything you learn here, you could actually do in C++. So if you want to take this code and actually just like recreate it in C++, it'll be like pretty intuitive for you to do so, I think. But yes, now that we know what for loops are, how can we use this to do everything we just did exactly the same way? So let's start with this, where we're doing a bar full of 10 empty boxes. And you'll notice like it's exactly the same, except we've pulled this line and this line into the actual loop itself, right? So now that we have that, we have variable equals 0 already. We already have the exact condition that we need because we wanted length to be 10, right? And then we're already incrementing it. The increment happens after all of these actions within the loop, right? Anything in here is completed. So if you want to think about it this way, the first statement here, the variable declaration and assignment, is happening before the loop runs. The condition happens each run of the loop. So every time the computer goes back and checks this, this is where the condition happens. So it happens during the loop. The plus plus I part happens at the very end of each run, right? So it'll go through this. What the computer does here, let's walk through. So it'll run all the code at the top. It gets to here, it says, oh, here's a for loop. Let's make this variable I. And then let's assign the variable 0, right? So I equals 0 at this point. Then it checks, yep, I is less than 10. It does that at the very beginning. So it knows not to run it if this is already false. So if you put I equals 10 here, this whole thing will just be like a wall false loop. It'll be useless. The computer will ignore it after evaluating this. And so it checks the condition. It skips over this first because the first run we don't need to increment it already, right? So it's going to go, yes, I equals 0. Looks like I is less than 10. That's true. And then it'll do all the actions here. Let's do like action 1 and action 2. So it'll do all the actions here, right? And then once it reaches action 2, it'll do plus plus I. And then at that point, I is 1, right? So it was 0 at the beginning, then it's 1. After that, it checks this again. It checks, is I still less than 10? And since it's 1, it'll go yes. And then it'll do the same thing and repeat until I is less than 10 is no longer true. So that's how for loops work. And so in order to do our empty box thing, we can actually just copy this over, right? Remember we were adding the box to the bar. So for this for loop, we'll just do bar plus equals this empty box, right? Yay. And we'll fix up our spacing a little bit. And so this should do exactly what our first question did, right? It'll give us 10 empty boxes. Yay. Wait, okay, well, we actually changed the max length. So, and we didn't reset. We didn't reset the bar. That's why this is doing that. So remember, we actually need to reset the bar so that everything we did before doesn't affect it. So yes, 10 empty bars. And this is why, like, it's really good to get rid of code that you normally don't need. Like, if I were doing this as a regular program, I would actually just take all this and delete it. Because what we're trying to do is like replicate exactly that, right? We're doing the exact same thing in different words. And so we either need to remember to reset the bar each time or just throw this all out. But I'll leave it here for reference. Like in the example solution, I haven't deleted them just so you can like go through and see the different ways to do them. So once you download that on the GitHub, you should be set. And you can just walk through it yourself. If you don't feel like following along through the video, if you don't want to hear me ramble on, that's fine too. So the second thing that we were going to do, so that one was using 2 loops to do the filled and the empty boxes, right? So now that we've already like sort of done this with a while loop, it's going to be really easy to translate this over to a for loop because we're essentially just like moving things into here, right? That's basically all we're doing, is we're just rewriting it as a for loop in this format instead of using a while loop. And so this is going to be very much similar to like what we had before. We're going to have one for like filled boxes and one for empty boxes. Oh, my hands are still so cold. It's making typing really hard. So it has this, and then we're pretty much going to have the same conditions as before. So remember, we have like the length, and we shared the variable between both of these, remember? So we probably want variable I to be declared like outside of this loop. So this is actually a really good reason to have it outside. So if you do, like, you could actually do this, or if you really want to, like, you could do I equals 0 here, and then like do this fucky thing. It looks really weird, but the computer thinks it's valid because an empty statement is the same as not having it there. But just make sure you have the semicolon here. Otherwise, it'll think that like the middle condition is actually like the first statement, and it's not going to know what to do with that. So I'll write it like this just so it looks a little bit better for you guys. But we can basically do the same thing here, right? And remember, we can replace this with like max length because we don't want to keep writing 10, right? So I is battery divided by, remember we were using percent per box, right? And then plus I. This is exactly the same thing as what we were doing in the second part of question 1. Exactly the same. It's just this part. But we're just writing it in a for loop. And so this, we can just copy this over. The filled part of the box is this. And then we don't need to manage this counter ourselves. We don't need to put it here. And it's just like a more compact way to write it, right? Oh, unexpected token. That is because I did something. Oh, it's because I put an empty for loop there. Okay. But yeah, now you can see like this is all of our filled boxes. And it's looking right. If we have 100, we have 10 of them. That looks cool. And so this next one, whoa, my keyboard is really fucky today. This one will be with the empty box, right? And what will this condition be? This one we'll actually have nothing at the beginning, right? Because we're gonna still keep using I. We don't want to reset it because we want it to keep the length at where it is. Remember, like for this one, we didn't actually have to write like length equals anything here, right? We just had it work from whatever length already was from our counter from the loop before it. So we can do that. And then we do I is less than max length, right? Because we want the full bar to always be 10 boxes or whatever the max length number is. Right now it's 10, but remember we can change it to anything. And so we can do plus plus I again because we're also trying to increment it that way, right? Like we need to make sure to add this so that the loop stops eventually. And so this should actually give us exactly what we wanted, right? And we'd have 0, we'd have 100, and just make sure to check like these conditions so you know that like everything's actually working and it doesn't just look like it's sort of working. Because sometimes you might find that there are little bugs in like the edge cases, or like maybe once the number switches from a boundary to another, it's like a little bit wrong. So it's kind of like that. Now, for our last thing, let's reset our bar again, right? Reset our bar again, and then we can actually try to do it with if conditions now, right? And so this is going to look very much the same for the third part of 1. So remember, we wanted to use like var I equals 0. Well, since we already use I here, we should actually just call it I equals 0, right? Because we already made a variable called I. We don't want to confuse the computer by giving it another variable called I. And in fact, most languages won't let you give it another character called I, or another variable called I, is what I should say. So this will be exactly the same condition. We're running through it from 0 to 10, right? 10 times, right? And then we just have our if statement again. Like we could copy exactly this. We can copy exactly this over from question 3 in the last, in the while loop section, because the conditions are the same here. We're just changing the loop. And so if we do this, like remember, if the length is under the battery percentage like threshold, then we want it to be filled. And then if it's not, then we just fill the rest with empty boxes. So if we refresh that, something went wrong. Let's take a look. What did we do wrong? Oh, it's because we used length. We renamed it to I. That's the thing. That's why it's nice to have like your variable names named properly, so you can like easily recognize when something is wrong. But yeah, I is what we're using to increment this instead of length. We named it something else. Can you also reset the bar in the initialization of 4? Yeah, you totally could do that if you want to. Just make sure that if you're doing like multiple ones, I think the syntax for it is actually like a comma. So you could do that. You can do something like this. So just make sure to separate the statements using like a semicolon. So it knows that, hey, these are the variable declarations and assignments. These are the conditions, and these are the increments and decrements. So for loops are pretty strict about like where you put things, right? So you definitely could. There are like a million ways to write any single thing in programming, especially in JavaScript. But it's just sort of nice because as long as you know how to use the tools, regardless of like how you write it, as long as it works properly, then you've done what you set out to accomplish, right? And so yeah, this works because like we've already tested this if statement right above here. And generally like you'll want to clean up your code a little bit, maybe do optimizations like this if you really want to. You can delete code that you don't want or like comment it out, things like that. But we did it. We've sort of taken apart this game and rebuilt the part that was like done for us in the last lesson. And now we know while loops and we know for loops. So that's this lesson. Loops are really exciting because once you unlock like the capability of doing loops, like you can now do like so many things in programming. And it's pretty amazing, like what you can accomplish with just loops and if conditions. So yay, go you. But yeah, that is the lesson for today. Let me know if any of you have questions. I know loops is like a little bit hard to wrap your mind around sometimes, because it is sort of like, it's sort of like math, you know, where if you're thinking about it, you actually need like practice, like having your mind thinking about it in that way. And so what I would suggest is, if you ever get stuck on a loop, or like you're stuck on what a loop is supposed to do, or like what the condition should be, just write it down. You can use like pencil or paper if you really want, or like you can type it out of like what each iteration of the loop is doing. Just break it down. Like some people, it helps to have like the visual diagram of what the loop is. Just write like, oh, what happens when like I equals 1 or like I equals 2, and write out like all the variables that and what their values are while you're doing the run. Another way that you could do it also is just to use like the console.log within the loop. So if you want to like print things out, if you're more of a sort of experimental learner that way, so instead of like trying to guess what the variables are, you can just have the computer tell you like what is in here, what is in your variable at this time, and it'll do that. Will you also be taught about loop inside loop? Yes, you will, in a bit of a later lesson. So I'm planning to have loops part 2 at some point. It won't be now. So I think the next lesson I might do is data types and arrays. And we're gonna go like far deeper into loops, so like you know more of what to do with them. Where are the best places to find practice problems? You can find a lot on the internet. Here, I can actually dig up some that are probably appropriate to this level. I guess the first recommendation would be to like try all this yourself, but I can dig up some and then I'll post it into the resource section of my Discord. And then you can find like all sorts of stuff there, hopefully. Or if anyone else knows some, you can feel free to share it there too. But the Discord channel would be like a really good place for all sorts of like links and resources of that nature. Throw stuff at the compiler until it works. Exactly. Just don't throw stuff at me. Thank you. CodingBat. Yes, CodingBat is a great resource according to Yui. So someone try that out. I know that there are like a lot of resources out there, and it might be a little overwhelming to find things. I know Code Academy is also something that is similar to that, and then it lets you like code directly into your browser too. So just some things to consider. If you have any other questions, feel free to just like tweet at me or like ask me in Discord. I'll be there. Otherwise, I'll see you all on Saturday for office hours. I think this time, actually, I don't know what we're doing. Are we doing Minecraft? I know that Jay set up the Minecraft server already, but we're doing a thing where he explained it a lot better in our last stream, but he's going to be gating the access for the server IP. So you have to sort of prove that you participated in a lesson, so we know that we're not letting in anyone malicious who's trying to like grief the server. So the server has a maximum number of like 24 people at a time, but it'll be really cool. It'll be the same server that we played during one of our office hours. And yeah, you can come hang out, try some redstone builds. You will have to like look for your own redstone, so you gotta work for it. It's part of the process. Saturday will be community Minecraft. Okay, yes, good. Saturday will be community Minecraft, so it's like right on the horizon. We're almost there. Yeah, online judge for beginner. Usually they'll have things too that if it says like judge or anything, it'll sort of like validate whatever the answer you print out is. So it'll be really useful for you to like be able to check your answer, and then it'll check it against like a bunch of different inputs too. So you don't have to like test it manually. So those are really good suggestions. There's also like Code Wars, HackerRank, LeetCode. I don't know if HackerRank and LeetCode are like at this level. They might be like a little bit further down the line, but those are like really good resources too. But yeah, it's gonna be fun. We're gonna chill around the Minecraft server on Saturday. And yeah, hopefully everyone was keeping up with this. I know that loops is like a little bit of a jump from conditionals. So hopefully everything made sense. If it didn't, let me know. And next time we're gonna learn about data types and arrays. So it might be a little bit, maybe more low key. You'll get to relax a little bit more. The journey for Redstone continues, exactly. But yeah, hope everyone has a great Wednesday, and I'll see you guys next time. Good night.